Assalamualaikum and hi. My name is Siti Haja binti Adnan.
My name is Nurul Atikah binti Muhammad Ruslan.
My name is Nurul Atikah binti Yaakob.
Hai, Assalamualaikum. My name is Nur Arkila binti Hasnul Hadi. Hai, Assalamualaikum. My name is Nur Adila binti Hasnul Hadi.
For this assessment, we need to investigate the ADC and DAC circuits based on the knowledge of science and engineering fundamental. First and foremost, I will tell you about the operation of these converters. The first converter is ADC. ADC is an electronic integrated circuit that converts a signal from analog to digital form. ADC takes sample from the analog signal from time to time, and each sample will be converted into a number based on its voltage level. An ADC works by sampling the value of the input at discrete interval time, provided that the input is sampled above the Nyquist rate, defined as twice the highest frequency of interest. Then all frequencies in the signal can be reconstructed. Second converter is DAC. DAC converts digital values to analog voltage. It performs inverse operation of the analog to digital, which is ADC. Afterward, it sends that analog signal to an amplifier. When you hear the digital recordings, you are actually listening to an analog signal that was converted from digital by a DAC. DAC produces an output current of voltage proportional to digital quantity applied to its input. So now I will tell you about the examples of each of the converters. For ADC, we have a digital RAM ADC for first example. Digital RAM ADC, also known as the stair-step RAM or counter-type ADC. For the second example of ADC, we have flash ADC. It uses a linear voltage ladder with a comparator rung of the ladder to compare the input voltage to the successive reference voltage. Move on to the DAC. The first example is binary weight resistor DAC. Binary weight resistor DAC is a variation on the inverting summing op-amp circuit. The second example of DAC is R2R ladder. The R2R ladder is a simple, effective, and accurate to create analog voltage from digital values. So I will pass this to my friends to explain more details about the examples of each ADC and DAC circuit.
Example of analog digital converter is digital RAM ADC, which is the simplest ADC circuit. The component used in the circuit is clock, counter, operational amplifier, and digital analog converter. Clock is used to send a pulse to the counter. Counter used to store the number of time processed that occur in the clock. Operational amplifier is a voltage amplifying device designed to be used with external feedback between input and output. Lastly, the component used is digital analog converter, which is to convert digital signal to analog signal. Next example is flash ADC. Flash ADC is a higher speed converter. The component used is resistor, priority encoder, and comparator. A resistor is used to implement electrical resistance as a circuit element. Next, priority encoder. Priority encoder used to compress multiple binary input into a smaller output. Lastly, comparator used to compare input voltage with its reference voltage. Digital analog converter example is binary weight resistor. The component used is AND switch, one for each bit applied to the input. Next is summing amplifier to add a current flowing to a resistive network. And lastly, the weight resistor ladder, where the resistor inverts proportionally to a numerical significance. Next example is R&to-R ladder network, which is a simple type of DAC. The R&to-R ladder network construct as a binary weight resistor that use a repeating cascaded structure of resistor value R&to-R. So the component used for this circuit is same with binary weight resistor, which is a summing amplifier and switches and weight resistor ladder.
I would like to explain about the operation of the circuit. For the analog digital converter, we choose digital RAM analog digital converter and flash analog digital converter. For the digital RAM analog digital converter, first reset the counter to 0. With all zeros at the input, the digital analog converter's output will also be 0. This is because analog voltage is bigger than output voltage. The comparator output will be high. When start returns to low, the AND gate is enabled and clock pulse get through the counter. As the counter advances, the digital analog converter output increases one step at a time, which continue until voltage output reach a step that exceeds analog voltage and the counter will stop counting. The conversion process is now complete and the counter will hold the digital value until the next start pulse initiates a new conversion. Next is flash analog digital converter, also known as flash or parallel coding. This analog digital converter is the highest speed converters. The input is fed out in parallel to several comparators. Each comparator compares the input voltage with its reference voltage and provide appropriate output. The output pattern analyzed by combinational logic to determine the output. Next, I would like to explain about digital analog converter. We choose a binary weighted resistor, digital analog converter, and R-to-R ladder. For the binary weighted resistor digital analog converter, each digital level input convert into equivalent analog output and utilize a summing op-amp circuit. Weighted resistors are used to distinguish each bit from the most significant to the least significant. Transistors are used to switch between reference voltage and ground, a reference voltage, and a summing amplifier that adds the current flowing in the resistive network to develop a signal that is proportional to the digital input. For the R-to-R ladder, this is the simplest type of digital analog converter. Requires only 2 precision resistance values. Each bit controls a switch between ground and the inverting input of the op-amp. The switch is connected to ground if the corresponding bit is 0. The less significant the bit, the more resistor the signal must pass through before reaching the op-amp. Thank you.
Now I want to present about task 2. Choose one of the converters, simulate their operation to confirm the function. This is simulation analog digital converter. The component required for ADC converter, the component include LED. This is ADC 0804. This is DC voltage. This is variable resistance. This is 10K resistance. This is 150 picofarad capacitor, and this is push button. So the calculation ADC output voltage is, this is a binary value which is 0, 1, 0, 0, 1, 1, 1, 1. And then we convert to decimal, we get 79. Next, analog voltage. Decimal value multiplied by step of size. And we get 79 decimal multiplied by 19.53 millivolt. And the answer for analog voltage is 1.54 voltage. Lastly, the obtained value for calculation, we get 1.54 voltage, while the simulation, we get the measured voltage is 1.55 voltage. That's all from me, and I will pass to Adila. Thank you. So now I will continue explanation from Kila. So I want explanation the ADC 0804, this ADC 0804 and this circuit diagram. So next explanation of simulation ADC converter. Okay, the explanation ADC 0804 is an 8-bit successive approximation analog to digital converter. The feature of ADC 0804 are differential analog voltage input 0 to 5 volt input voltage range, no zero adjustment, built-in clock generator. Reference voltage can be internally adjusted to convert small analog voltage span to 8-bit resolution. So the voltage as VREF stroke 2 pin 9 to ADC 0804 can be internally adjusted to convert small input voltage span to full 8-bit resolution. VREF 2 pin 9 left open means input voltage span in 0 to 5 volt. So have a look at the table below for difference VRF stroke 2 voltage and its corresponding analog input voltage spans. So the circuit the ADC to convert a given analog input, then accepted the corresponding digital data and display it on the LED array connected at P0. For example, if the analog input voltage V input in 5 volt, then all LED V in is, for example, if the analog input voltage Vin is 5 volt, then all LED will glow indicated 1, 1, 1, 1, 1, 1, 1, 1 in binary, which is the equivalence in decimal. Data out pin D0 to D7 of the ADC 0804 are connected to the port pin P1 to P10 to P17 respectively. LED D1 to D8 are connected to the port pin P00 to P07 respectively. So lastly, the entire circuit can be powered from 5 volt DC. ADC 0804 has active low output, and the instruction CPL A complement it to have a straightforward display. For example, in input, if input is 5 volt, then the output will be 1, 1, 1, 1, 1, 1, 1. Okay, that's all from us. Thank you.